Welcome to Ask and Learn.
Let's show that this series is absolutely convergent. So here we'll go ahead and look at a similar series, but this time we'll take absolute value. So here there's absolute value. So all that will do for us is get rid of the negative 1 to the n power. And let me explain why here. This is because n squared and arctan of n are both positive in here. So technically arctan could be negative if you think of the graph of this. But as long as n is positive, then arctan is positive. So that justifies why we can drop the absolute values. And then this series, we know this is less than or equal to the largest that the arctan could be is this horizontal asymptote at pi over 2. So I'll just go ahead and replace arctan with pi over 2. And here you can pull out that constant. So we're using a few tests here. You can see from the inequality that we're setting ourselves up to use the comparison test. So now we have to look at our upper bound, this new series over here in blue, and that's a p series. So the series converges. You would apply the p test with p equals 2, and that is bigger than 1, so the series will converge. So now the upper bound converges. So by the comparison test, the lower bound also converges. And we conclude that the original series, is absolutely convergent. So let me just go ahead and call this, instead of writing this whole thing down again, let's just call this star. The series star converges, is absolutely convergent.